Hey guys, good evening. Apologies for joining a bit late here. So there was some technical challenges, so which we were trying to fix. Uh, Apologies for. So let's begin our session. So I know we are a bit late, but I think it's never too late. Let's get started. Hey guys, good. Okay. Today's agenda for a class is machine learning. In our previous discussion, we have been talking about what is data science, how the umbrella of data science looks like, and eventually, on top of that, we were talking about what is artificial intelligence and how things are linked, right? So, when we say data science as a position, so what does it comprise of? So, that is basically what we were looking at, and that is what the objective also. But now, in today's class, we will be talking about machine learning and we will be understanding how exactly machine learning is used, what are the different things which are comprising my machine learning topic. So that's pretty much what the agenda of today comprises of, guys. So I think let's get started. We all are excited towards machine learning anyway. So let's understand what is machine learning and let's try to build up a fair sense of things into machine learning computations. So what please? Hey Pranav, thank you so much for joining us. And as always, uh, we are trying to be as interactive as possible. So I am monitoring my chat. So any questions at any point of time, I'm more than happy to answer it. So let's try to ask as many questions, guys. It's pretty much a live stream. So please feel free and then post up your query. So I'll try to take it uh, as enough time permits here. But I'll try to answer most of the questions. Cool, guys. So let's get started. Before getting started, so my name is Arpit Jain, and the reason why I am here with you is because data science is what my passion is, and I really like sharing my expertise with people. So I'll just give you a quick introduction about myself as well. So uh, I have around good 9-10 years of experience in analytics into multiple varied domains. So that includes telecommunication, finance, cloud, manufacturing, automobile. So that's pretty much how I've been journeyed through all of these different sectors. I'm currently working as a lead data scientist in a leading software telecom company. And during my journey, I have been using the different data science tools and techniques, which includes statistics, machine learning, along with that deep learning. And also now I'm working as a person who is pretty much towards the full stack deployment of the models as well. So that's how I've been. So I'm pretty much well versed with the technologies. And along with this, I also talk to students regarding their career mentorships and everything. So I'm also a public speaker. So I do enjoy talking to people, guiding the students regarding the career advices and all that. So any questions in general as well, guys, always feel free to reach out. So more than happy to talk. So that's pretty much who I am. But now talking about today's agenda, it's pretty concise. So we will be talking about what exactly machine learning is, and that is what I will be trying to give you a fair idea of how machine learning is used. I mean, even before that, what is a machine learning? What do you mean by machine learning? And what all are the different aspects of machine learning, right? So, and that is where we will be talking about things. Cool. So, as the name suggests, guys, as the name suggests, what do you think machine learning is? So, machine which is learning, simple, right? So, when I say machine learning, so even the name suggests the similar thing, right? So, machine learning, I'm trying to make the machine learn something, right? And what is that learning? What learning is machine having? So, and if you remember, that is where we talked about the things about the learning process. We are trying to mimic the activities or the things which human being is doing, right? So that is a human brain does. So it can be further subdivided into two broad areas. So that is where we, if you remember, we talked about strong AI and the weak AI. Strong AI, where pretty much every single thing what a human does, like a human brain does almost like every single thing. I talk, walk, I can eat, speak, hear, watch something. I can understand things. I can process things. I can calculate things, right? So a human brain does multiple different things, and that is pretty much what strong AI talks about. So we're trying to mimic something, trying to mimic the intelligence of a brain, which is capable to do every single thing which you can think of, like robots. Right? So we talk about robotics and all of those stuff there in the strong AI part. But there is another section of artificial intelligence. That's where we talk it as a weak AI section or a narrow AI. That is where we say that we have limited things which we want to process. We're talking about only limited set of problems which we're trying to solve. Or we also say that one problem at once. Like for example, I say, uh, being from a very simple example giving, so same healthcare industry problem. I say, uh, I have few patients coming in. I want to detect whether that patient is having cancer or not, right? So one problem statement. Or I want to say that, okay, if I have a set of n employees in my organization, which employee is more probable to maybe go out of my organization, maybe to put a resignation? Let's have multiple such problem statements, but all of them has their own specific objective. Like when I say, find out whether the person is having cancer or not, I'm least bothered with any other aspect of it. I'm least bothered whether the person is going to play an IPL cricket or not. Does that make sense? No. I'm not looking for that aspect. I'm only trying to solve one purpose, one objective. That could be anything. We will be talking about those objectives, obviously, because that is where the distinctions would come. That is where we will be saying, okay, if this is the objective, this is what the type of learning it is. Logically, also, I cannot have the same learning for different objective statements. And that is where machine learning comes into picture. So with machine learning, which is actually a sub part of my narrow AI or a weak AI from artificial intelligence, we say that now we are trying to solve a very specific problem statement, a very specific problem statement. And this problem statement obviously could vary. Like, for example, I could say I'm trying to find out whether the person will move out of my plan or not, or what is the salary of my expected employee, or what will be the price of my house, which is having this and this feature, or if I have pool of certain customers, who are my loyal customers, who are maybe not so loyal customers. So all of these problem statements, and there are many more, guys, many more. We will be talking about all of them with time. But situations where we are trying to solve a particular problem statement with a singular objective, that's where machine learning comes into picture. But why the term machine learning? I could have simply said problem solving, right? Why machine learning? So the reason why I'm calling this mechanism machine learning is I have the respective set of information. So whenever I say that I'm going to solve this problem, a problem of say whether the patient is having cancer or not. So what's happening in this process is a human brain, what it does, it tries to look out if the person is having fever, or if the person is having some swollen glands, or if the person is having some hair loss. some symptoms, right? And yes, with the experience, yes, a doctor knows that if the person is having this symptom, he or she is probable to have, he is probably a cancer patient. So what's happening here, guys? Try to relate it. What's happening? Whatever the problem statement is, forget about the machine learning. Think about from a human brain perspective, or a doctor in this case. How doctor diagnose this? If the patient is having this, and this symptom, yeah, he is probable to have cancer most probably. That's what happens, right? And yes, and how do we know that and this symptoms relate to having a cancer? With experience, right? So with experience, with some learning, and with that is what the doctors have learned in their own masters, right? So that's what they have learned. That's what they are specialized on, right? And me being an engineer might not be able to tell, okay, based on this symptoms, person is having a cancer. I cannot tell because I have not learned that. I'm maybe good in something else, right? But that is what a doctor is specialized on, right? That is what the specialty is. And that is where he has learned those skills, right? And based on this learning itself, the doctor is able to identify or diagnose whether the person is having cancer or not. That is where the learning process comes into picture. So whatever the problem statement is, whatever the situation is, what happens in this case is we always try to relate with our past experiences. To solve a problem like these, we always try to relate what is my past experiences. We try to understand, okay, if these are the similar patterns which has happened in the past, there is a high probability, there's a high probability if something similar is seen going forward, yes, it could be a situation of cancer or maybe some other problem statement. That's where the learning concepts comes into picture. But if you understand, this learning is more or less a human affected, right? And obviously, if we have a human intervention in this place, there are chances of errors. There are chances where we might miss out something, we might see something else, right? And where the objective of machine being capable of having those learnings came into picture. So whatever learning this doctor had to identify with the help of XYZ symptoms, the person is having cancer. Now, the similar learnings is being fed to a machine. And this machine could be as simple as your laptop also. This could be as simple as your maybe a home desktop. So I'm trying to just say any machine, any computational power which is able to have this learning that, okay, with the X things which is happening in the past, with the help of this features or symptoms, now I can relate whether that person is having cancer or not. That is where we are developing a capability in a machine to say that, yes, have that learning, and with the help of this learning, now you are capable enough to communicate whether the person is having cancer or not. And that is where the concept of machine learning came into existence, guys. Right? So I hope you get the context. We're trying to solve the same problem, or I would say it's a similar problem, what a human is doing now with the help of machine. And that is where the similar learning which the doctor had, I'm trying to feed it into machine. But try to understand again the complexity behind this. Yes. So a doctor, instead of only diagnosing a cancer, he can still do lot many other things, right? But that is where we have a limitation in the machine learning concept, where if I am making this system, or if I'm making this machine learn a specific set of things like a more like an interdependency between certain symptoms and being cancer or not, then the machine is only learning that one single thing. It will only be able to tell with that learning whether the patient is having cancer or not. The machine will not be able to tell whether the person is able to maybe walk again or not, or something like that. It is only going to solve that one single purpose, nothing else. That is where again the machine learning concept comes into picture. But the main question still lies. So when I say the doctor is having this learning, that means when you understand it theoretically, how the doctor is learning. Doctor is learning by reading some books, by understanding what has happened in the past. Based on the experiences, people have written some books, and those books are giving that information that, okay, if the person is having this symptom, this trait, this things, then yes, there is a high probability that we can look forward towards the person being cancer or not. But that is where we talk about some information which is already available with the which was available with the doctor, based on which now the doctor is capable enough to identify that yes, there is a relationship between this symptom and the person being cancerous or not. That is where we talk about data pattern identification. Think about it. When I say information, any piece of information is my data. And data, as we have already discussed, could be of two types: quantitative and qualitative. By quantitative, I mean some numbers, some numerical information, maybe my person's weight, my person's height, my person's age, something, some more other, maybe sugar level, my this level, my some other metrics of a medical field. And along with that, some qualitative information, maybe what food the person has been eating, eating habits, hygiene, a lot of things are there, right? So all these traits, so all of these are what my traits, my symptoms, maybe having high fever, or maybe having loose motions or diarrhea or vomiting, or having bruises somewhere, or maybe having some pale skin, hair loss. All these things are some information, and how these informations are classified: two types, qualitative and quantitative. So ultimately, with the help of these qualitative and quantitative informations, the doctor was able to relate. And that is what now these informations, which could be present in the past, are now being fed to the machines, and the machines are being trained. Machines are being said that yes, please look at these different traits, please look at these different individual patterns, through which we can say, yes, if these and these patterns are you able to relate, are you're able to see that may relate to person having cancer. And yes, that is where the data pattern identification comes, guys. That is where we say that how exactly we are making sure the machine is able to learn something. What are the inputs here? What is the machine getting? How the machine is learning these things? How the machine is now capable enough to say that yes, the person is having cancer or not. So by this, I'm saying by only giving some relevant information, which is the data point, which is coming from my past experience, my past history. That is what we talk as historical data. So from the historical data, from my past experiences, the machine is able to identify some patterns, some trend, some things based on which the machine now can relate similar way what the doctor was able to relate, that yes, based on this and this and this and this pattern or some features, yes, there is a probability that the person will be having cancer. And this is exactly what the core structure of machine learning looks like, guys. I hope you are able to make the sense out of it, right? So that is where we talk about where machine learning sense. When I say machine learning, it is basically I am telling the machine to learn the similar things what a human can do, but only one objective at this time. So that is what we're trying to understand from the machine learning perspective, how this learning would be affected what all different things would be there, that is what we will be looking at, guys. So let's move ahead. So we already discussed this in our last class. Artificial intelligence is a set of algorithms. So AI is nothing but is a set of rules or set of algorithms and intelligence to try to mimic the human intelligence. The objective is here from the AI to mimic my human intelligence. That is ultimately what my goal is. Because whatever a human is doing, I'm trying the similar things can now be performed by a machine as well, based on which certain algorithms, certain rules, certain protocols. The set of these protocols, set of these rules and algorithms, that's pretty much what I would expect a machine to take in. And with the help of these algorithms, machine should be able to replicate what a human intelligence is doing. And machine learning is one of these sub areas where, or is a set of algorithms, and deep learning is one of those machine learning techniques. So machine learning is some set of protocols or algorithms which is trying to mimic my human intelligence. Again, human intelligence is a very vast field. A lot of different things are there, but with the help of machine learning, we are going to be focused towards certain specific problem statements through which we are trying to understand how this can be solved. And deep learning is one of those machine learning specific techniques where again we talk about certain advanced mechanism in which we are still trying to solve one problem statement, but going to be part of my machine learning sub techniques. That is what we are looking forward to and trying to discuss from the artificial intelligence and the machine learning perspective. So going forward, let's try to read up what is machine learning. So machine learning includes a section of AI and deep learning is a part of machine learning. So what do I mean by that? If you remember, what did I say? So artificial intelligence is where we talk about it is having two subtypes, which is weak AI and strong AI. Weak AI, that's where we say one single objective. And we say machine learning coming into picture here. Because machine learning is intended to solve only one single problem statement. And in strong AI, we say multi-problems. And we say that is where robotics comes into picture. Or AGI, artificial general intelligence. Again, it's a research field. Research is still going on. So for again, that is where my intent is for the machine learning part, which is pretty much coming inside my weak AI of artificial intelligence. And machine learning itself has a subtype of deep learning. We have some specific algos coming into picture. That is how the core structure of artificial intelligence, machine learning, deep learning looks like. Guys, so always have this mindset. So artificial intelligence, where we say we have weak AI and the strong AI, and weak AI has one single objective and strong AI has multi-objective. And we try to understand how things can be sorted here in terms of artificial intelligence. Okay, so coming back here, machine learning, as I say, it includes a section of AI By a section of AI means artificial intelligence is a bigger umbrella. That is where both the subparts comes into picture, weak and the strong. The general intelligence, that is where robotics also is a part. And also weak AI, machine learning is a sub part of artificial intelligence. So machine learning is not the only artificial intelligence you can think of. It's a section of my artificial intelligence. And deep learning is one of the parts of machine learning. So when I say machine learning, technically what it means, it is certain set of algorithms. So when I say set of algorithms, guys, again try to understand. Let's go back to our same discussion. When I say I'm trying to make a machine learn to identify whether the person is having cancer or not. So how does the machine identifies that? In the background, there is some sort of mathematical calculation, some sort of pattern identification happening in the background. And that is where we have some set of rules, some set of algorithms, which does that for you. So some set of algorithms, some set of rules, which is now able to identify that yes, these are the things based on these algorithms and rules. The machine is able to identify the right patterns, and based on these patterns, it can say, yes, the person is having cancer or solve my objective. So this set of algorithms again, so deep learning is another few set of those algorithms which are sub part of machine learning. So we will be discussing that as well with time. So my objective here is to learn the data and give the business meaningful outcomes. So when I say learn the data, when we say learn the data, I'm only trying to say that my objective is to make sure the machine is able to identify some hidden informations. What are those hidden information? Again, go back, think about the same perspective. When I say a doctor is able to identify it based on certain symptoms, that is my hidden information. That is, I mean, a normal person cannot see that, right? Even if it is there, I'm not able to relate. So a data with no relationship does not really make any business sense. That is where the objective is to make sure that the machine is able to learn that data. Learn means it is able to identify the patterns, the symptoms. Likewise, it can relate it to some business meaningful outcome. And here in this case, my meaningful business outcome is whether the person is having cancer or not. And learning the data means identifying the right set of symptoms, right set of patterns, so that it can relate between the symptoms and my business outcome. And that is what the objective we are trying to solve from machine learning, guys. So my objective here is pretty simple. I'm trying to make the machine learn the data and give some meaningful business outcomes. So I have been using this term quite often. So machine learning includes pattern recognition, which includes the ability to recognize the patterns in data. Very interesting point, guys. And this is in fact one of the very important points. So pattern recognition can actually be seen in multiple different ways. Again, think about it. When I say the symptoms, right? So basically, symptoms are still there. I mean, a normal person can still see those symptoms, right? Yes, I could see the person is having fever. I could see he is having bruises. I could see his skin is turning pale. But whether I'm qualified enough or I'm having those learning that can I directly relate and say that, okay, yes, this person is having cancer or not? No. That is where I say, based on whatever informations we have, the data points we have, the machine should be able to identify the pattern, should recognize the patterns, the hidden information based on which it can establish the relationship. So right now I have been talking about only the symptoms. So think about this scenario. So for example, suppose a very classic example, I have this stock data. Okay. So I have this stock price. Okay, no, not here. So suppose this is my time component and this is my stock price. So we know with time the stock price changes, right? So this is how I have been seeing the trend of my stock price, guys. So what does it mean? As long as my time component is increasing, so I am going ahead in my time, and this time component could be a day factor, month, year, whatever it is, I am seeing somewhat an upward trend. Yes, there are some peaks, there are some lows, but in general, I'm seeing an upward trend. Correct? So, with the help of this information, I can say the stock price. So, suppose this is for 2010, 2015, 2020. So probably if I extend this further to 2025, I might see this stock going somewhere here. So how did I find out this point? How did I come to a conclusion of this point? That is purely because in the past we had certain data points which was lying from here till here. This is what is called as historical data, or the data with the help of which now I'm trying to identify the pattern which can give us an information of something which is going to happen in future. So I'm trying to understand that yes, with the help of this piece of information, with this piece of historical data, I can somewhat with confidence say the stock price of 2025 would be lying somewhere here. But what if imagine I do not have any information of any so whatsoever data? I do not have any information whatsoever. So in this scenario, I actually cannot say what will be my stock price of 2025 because I have not seen the history. I do not know what is my history. So and on the year 2025, I could it could still be here, it could still be here, I could say it is still here, anywhere. I do not know where it would be, but since I have the historical data, so I had some sense, right, where potentially this data or the value of my stock price could be. That is where again the learning coming into picture. So we have to think about this aspect from a different perspective. So based on certain information in the past, that is where the historical data coming into picture. We're trying to say now what could be the potential future going ahead. That is what the objective of my machine learning is, and that is what we are trying to say in this part, the pattern recognition. So this pattern recognition technically means, so from the historical data, identify the right set of patterns. And with this set of patterns, you should be comfortable enough to take a decision of whatever business outcome you're looking at. That's what we say practically pattern recognition, what it means. Correct? And the pattern should be trained to show the output in a desirable manner. Again, very important point, guys. So, whatever my business objective is, trying to solve from this, I'm trying to find out the details from that specifically. Okay. Hey Rahul, thank you so much for updating in the chat. So I'm not sure why the voice is low. Let me quickly correct it. So I'll just increase the volume on my end. Okay. So I've just corrected it also. Let me know if still there is still an issue. Thank you so much for updating it. Cool guys. So that's pretty much what machine learning means. But now let's move ahead and try to understand what does it comprise of. So we were talking about these two different ways in our earlier class as well. So machine learning is technically subdivided into two different ways. First is a supervised method. Second is an unsupervised method. Okay, we call this as supervised training, and the second is unsupervised training. So how does it change? How does it differ from each other? So if you remember, for the supervised methods, we say from the data perspective, we have the outcome available with me, and also we say the data points which we are trying to relate. So what do we mean by that? For example, same cancer problem. I have symptom 1, symptom 2, symptom 3, symptom 4. And this ultimately is saying that yes, the person is having cancer. So a set of this input feature is correlating to my this, which is my output feature. So I have a relationship of output which is directly dependent on input. And that is where supervised method come into picture. We say that the moment I have an outcome as well with me in the learning process, so in the past experiences, what are we saying? Symptom 1, 2, 3, 4 is related to the person having cancer. Or whatever the case. So I know what is my stock price for this time, right? So I have the ultimate output value also with me. That is where I have the output variable, which is directly dependent on the input feature sets. That is where we say, yes, this is what we call as my supervised method. So I have the supervision where I can relate my inputs directly with my outputs. But on the other hand, when I talk about unsupervised method, so in this case, I do not have the outcome. I only look at this data points. So again, there are certain classic examples. So if you remember, I was talking about loyal customers. So for any brand, suppose imagine I'm running a online merchandise store. In this online merchandise store, I have a pool of different users or customers. From this pool of customers, now I'm trying to find out who all are my loyal customers. So again, this information is not available explicitly. I do not have this information. Loyal customers, I do not have this. I'm trying to kind of group the available pool of 1,000 customers into smaller groups. So maybe I'll be having 50, 80 or 100 odd customers who are loyal. And their trends or their traits or their patterns would be somewhat similar, right? So based on this patterns I have, symptom 1, symptom 2, symptom 3, or say column 1, column 2, column 3, column 4, I'm trying to group them into particular groups. So each of my rows is now getting bifurcated into respective groups. That is where unsupervised training would come into picture. So we will obviously see each of them one by one. But let's start with the supervised method. So supervised method, as we say, this method or the learning algorithm take the training data and its associated output, that is the labels or the responses with each data samples during the training process. Pretty simple, straightforward also. Supervision. I have the supervision in my training process. So now in the learning process, the algorithm, the training data is associated with the output labels. So whatever my output is ultimately at the end, it is visible to each of my training samples. And what do I mean by that? Heavy terms, training samples, labels, outputs might look tricky at this point of time. Still the same thing, guys. So when I say labels, it is nothing but output, which is whether the person is having cancer or not. When I say training samples, I say the feature sets. There are a lot of different samples. I cannot say that the person is having cancer just by seeing one patient in the training process. I need to see thousands and thousands of such patients to identify the patterns, right? And that is where we say the data samples. Data samples, again, from a data perspective, is nothing but different rows of information from an Excel file perspective. One row is one patient, second row is second patient. So I need to give information of maybe thousands and thousands of such patients and their respective traits, their respective symptoms related with the actual label or the output, which is whether the person is having cancer or not. So each of my training samples or my respective patients are actually being fed with their actual responses, the labels of my information. That is where the supervision comes into picture. So the symptoms, the objective here is the output is getting linked with the symptoms we have. And that is what we're trying to look at. So the main objective of supervised learning algorithm is to learn an association between my input data samples and the corresponding outputs, right? So that is what we talk about. So once we have identified the right set of patterns, so how exactly these patterns are linked with my input samples. So what exactly we're trying to find out? So this input data sample patterns should correspond to my output. And that is where the supervised learning comes into picture. We say that now my input data samples are corresponded to my output, that yes, now with the help of these and these input patterns, I can relate that yes, the person will have a cancer or not. That is what the main objective of supervision method is. So we're trying to find the right association, the linkage between my one input sample and the multiple input samples and the corresponding outputs. So based on the objectives, the ML task, so what problem statement, what outputs, the different type of outputs, then supervised methods can further be broadly classified into two different classes. One is classification problem, second is a regression problem. So two further subtypes of my ML, which is classification and the second is regression. So how does that happen? So classification, as you can see here, 0 or 1 or true or false or yes or no. So a problem statement where the objective is in terms of a class. Like I say, the person is having cancer or not, yes or no. Or whether a particular customer will move out of a plan, like move out of my organization or not. Churning problems. So true, false, yes, no, 0, 1. Problem statements where my objective or my output is in form of a class, like 0, 1, true, false. That those type of supervised learning algorithm are called as classification problems. Again, we will be going in deep in this, how classification algorithm will work. But right now, what you have to keep in mind is supervised learning method, the objective of the output where it is more towards classes, it is called as a classification problem. The second is a regression problem. So a regression problem is the one where the objective, where the output is more of a continuous number. Like when I say a stock price, or when I say a salary of an individual, or a price of my house, it's not a class, it's a number. So any output statement, any output which is more of a regressed numbers, that is what we talk about as regression. That is what we talk about as regression. So classification is more like 0, 1, true, false, yes, no. And regression is more like the outputs where the outputs, the output is more of a number, like a continuous number for me. Like a salary, price, all of this coming under my regression types. So that's broad classification of my supervised methods. Next, another very important type of my machine learning problem statements are unsupervised methods. So unsupervised methods, as the name suggests, it is opposite to supervised ML method. So when I say opposite to supervised ML method, so in supervised method we have an output, but in here we do not have any supervisor to provide any sort of guidance. So we say that in these scenarios, we do not have any output. We do not have any place to find out the relationship between my input parameters and the output because I do not have any output as such. So the algorithms, the methods where I do not have any supervision or any sort of guidance to find the relationship between my input and the output, that is what we call as unsupervised learning. The main objective of unsupervised learning algorithms is to find the interesting patterns from the available input data with no target variable. So whatever inputs we have, whatever interesting patterns which we can look at from my input feature set, that is what we try to look at. That is what, based on which we try to find some interesting patterns. And but there is no linkage between these patterns with my target variable. I'm only talking about the interesting patterns. That's it. And based on these ML tasks, the unsupervised learning algorithms can actually be further, can be divided into multiple types. So first is clustering. Clustering, as the name suggests, we are trying to group something. So the same problem statement as I was talking about, if we are trying to find out a group of loyal customers from my available database or like a customer segmentation. I'm trying to subdivide my customers into two, three different categories: good customers, bad customers, loyal customers. So, based on these customer traits, their patterns, I'm trying to further subdivide them into smaller groups. And yes, once we have these groups, we probably would be able to take some business decisions or strategic help outs for my business, right? Certain fancy algorithms which comes under the clustering part are k-means, knn, so we will be discussing about them in detail with time. The second type of unsupervised learning method is association. Very, very, very interesting type. So association is that's where we talk about market basket analytics, my recommendations coming on Netflix. So what are these? So very classic example, if you go to any superstore to buy things, right? Have you seen how the things are aligned? How the things are aligned in different aisles, how they are set up? Have you seen a milk right next to some say machineries? Have you seen that? No. Milk is generally placed near to bread, butter, something of that sort, right? So things which can be associated together, market basket analytics. So we always try to find out some sort of association between different products which has the highest probability of being used. Again, very fancy use case of market basket analytics. We will be discussing about this as well. But even more common than that is Netflix. Every now and then, people are talking about Netflix. We are using Netflix. So when you log into your portal, you must have seen recommended for you, recommendations for you. How does that recommendations coming up? There's no target there. There's no learning happening. It is just because you have certain traits. You watch maybe a horror genre movie, or maybe you're more towards crime thrillers, or maybe you watch stand-up comedies a lot. So based on your characteristics, your traits, your methods, you are being mapped with certain products, recommendation systems. Again, a very classic problem statements of unsupervised learning, the recommendation engines. That is again also what we will be talking about. But that's on a overview perspective, how the machine learning is further subdivided. So we talk about two broad things here, guys. Two broad things, machine learning. First is supervised methods. That is where we have the targets. Regression classifications comes into the picture. The second is unsupervised methods. There is no target. We always talk about the interesting patterns from my data with no relationship with my target. Classic examples, clustering, associations. Cool. So with this, we are pretty much done from today's perspective. So this is what I wanted to cover for today. In the next discussion of ours, I would like you to take you towards a couple of use cases. So in the next class, we will be actually going in deep towards our Netflix use case. So we'll try to see how Netflix is using the information in different aspects. So we'll try to find out those details as well. But that is what where we end today. So we have been discussing about the types of machine learning, and I hope you have got that. Any questions, guys? Anything? Please put up your question in the chat. I'm more than happy to take that. And if there is nothing, we are good to close. And I shall be meeting you on day after, and we will be discussing about one very strong use case uh, from the Netflix. So we will be discussing about that, how exactly things happens. Cool, guys. So with this, I take your leave. So thank you so much for being patient and thank you so much for listening to me. So as always, let's stay connected and we'll see you each other day after with another use case of machine learning where we'll be going deep towards Netflix. Thank you so much. See you the next day. Bye bye.